You are watching the 3.1 lesson video on average rate of change. Now, last year in 8th grade, you probably did a ton of work, or you remember graphing lots of lines, and the way that you graphed them was where you started, so the y-intercept, and then the slope told you how to move. So in this unit, we're going to talk about the average rate of change, which is really the same thing as slope. And here's a few formulas that you might remember from last year. It's the change in y divided by the change in x, which is the opposite of how we plot points. So a lot of times people get confused, so try to keep it in order. I know you've done a ton of work with slope already, but this year I'm just going to call it average rate of change. So it's like a lot of things that we've said in math already this year, potato, potato. So it's a change in y over the change in x. We also refer to it as a rise over run, or the vertical change divided by the horizontal change. Here's a formula. You might have used it last year. I personally don't like this formula. I like to show my slope in a table instead. All right, so what are the different types? So question 1 says, on each coordinate plane below, graph a linear function that has a specified rate of change. And we know that rate of change is really the same thing as slope, potato, potato. So if we wanted to graph a line with a positive slope, we would just read our graph from left to right, and it should be increasing because it's positive. If it's a negative slope, from left to right, it would be decreasing. A zero slope would mean that it's not growing or decreasing at a constant rate. It just stays as a flat line. And undefined would look something like this. And notice how I've added arrows onto both ends of my lines. We will get into the habit of doing this as the year progresses. Okay, so now in example number 2, we need to find the average rate of change of parts. It says A through D, but somehow it got switched to 1, 2, 3, and 4. And the way that we show the average rate of change with most of these is by setting up a table. But lucky for me, if we look at question number 1, we see that it is written in y equals, and I'm going to write this right underneath, y equals mx plus b form. When we see this, we should be jumping for joy because whatever number is in front of our x is our slope. And the average rate of change is the same thing as the slope. So 0.6 is our slope. That's it. Okay, number 2, we have a table, which I love. And what we're trying to find in tables is patterns. So how are my y's changing? So how do I get from 7 to 10, 10 to 13, 13 to 16? I'm adding 3 every single time. All right, what's going on with my x's? How do I get from 9 to 14, and 14 to 19, and 19 to 24? Well, it looks like I'm adding 5 every single time. So my slope would be the change of y. So how do my y's change? Divided by my x change, which would mean 3/5. Hey, wait a minute. Isn't 0.6 and 3/5 the same? Kind of cool. Okay. 3, let's take a look at this one. So remember, when I'm looking for average rate of change or slope, I need to first of all read a graph like I read a book from left to right. Let me just make this a little bit bigger to identify a couple points. Like I definitely like, what's a point that I like? I like this point. That's a little high. That point, oh my gosh, what a disaster. I'm sorry. Let's fix this. All right, let's see if I can get a little bit closer. This point right here, because it's intersecting in a nice intersection. And what else? It looks like the y-intercept is a nice point. But if you look at all of these points, I didn't pick any of them because they didn't intersect at nice intersections. So I try to keep it easier on myself. All right, let's find the slope. How did I get from the left point to the right point? I always go from left to right. So what did I do? Well, I had to go up 3. So up 3 and to the right 1, 2, 3, 4, 5 spaces. So my vertical change is 3 divided by my horizontal change, which is 5. Again, we have the same slope. This is really cool. All right, number 4 is a little different. They just gave us 2 points, but what's stopping us from making a table? Absolutely nothing. So let's do it. I'm going to make an XY table. The first point is -4, -11, and the second point is 1, -8. All right, let's figure out how these are changing. To get from -11 to -8, I added 3. And how did I get from -4 to 1? You probably guessed this already. I added 5. So my slope is a change in y divided by the change in x, which is 3/5 once again. In this leading question down below, it says, what do you notice about all of these different types of average rate, or all 3 average rates of change? That should say 4, because there's 4 problems. And it says, does this mean they are the same function? Well, can 2 lines have the same slope but have different y-intercepts? Well, let's see. The answer is yeah. Look at 0.6x, which is really 3/5, minus 10 is my y-intercept here, and check it out. Does that look like a -10? No, that looks like a +2. So if I were to write my line here, this one would be y equals 3/5, or I could also write 0.6 if I want to, because it's the same, 3/5 x plus 2. So they have the same slope, but they have different y-intercepts. And some of you might say, oh, this would mean that they're both growing at the same rate at different points where they begin, which means that they'll be parallel lines. So I'll give you a minute to copy that down. Moving on to question number 3, one thing that I do want you to constantly make a connection with, and this is just throughout the course of algebra itself, is make a connection between the function, the table, and the picture of a graph. So if we read question number 3, it says that every table below represents a linear relationship. So that means my average rate of change is constant. It will never differ. Then says determine which table has the greatest rate of change over this domain. Well, some of you might get thrown off by that, but if you think about it, what it's saying is the domain, or the x values, are going from -infinity, so as far left as you can get, to as far right as you can get, which who cares, because a line has an average rate of change that is the same throughout every part of the graph, so between every 2 points. So that's a little tricky wording, but all it's saying is find the average rate of change. And in this case, find which one has the greatest rate of change. So let's get to it. We just need to calculate the change in the y values divided by the change in the x. And because these are all linear, it said it in the problem, we just need to figure out how we're jumping for our y values in this first part A. It looks like we're actually adding 5. And what's going on with my x values? Looks like I'm adding 2. So my slope here is 5/2. We can also write that as a decimal. It might help us a little bit better, just to show that 5 divided by 2 is really 2.5. Okay, let's do the same thing with part B so we can compare. How am I getting from each one of these 2 points? Well, 2.5 to 4. It looks like I'm just adding 1.5 each time. And how about what's going on here? I'm going from -7 to -6 to -5 to -4. That's pretty easy. I'm just adding 1. So my slope would be my change in y divided by my change in x. Well, anything divided by 1 is just itself. All right, obviously A is looks like it's our winner right now. Let's just verify part C. Ooh, look at some big numbers. So how am I getting from negative 31 to negative 21 to negative 11 to negative 1? Looks tricky, but it's really not. Looks like we're just adding 10 every single time. Looks like we're adding 10 every single time here. So that's a slope of 10 over 10, 10 divided by 10. My y's divided by my x would just be 1. So our winner, which has the greatest rate of change, or my greatest slope, would be A. I'll put a star next to it. All right, question number 4. We're now comparing the actual functions. And it says which equation has the smallest rate of change. Oops, I wanted to use my highlighter. The smallest rate of change, or the smallest slope, over this domain. So we could make a bunch of tables and use our x values, our domain values of 5 to 7, but let's think about this in a smarter way. The domain, that could have said negative 1 million, negative 1 million to 20,000, and it wouldn't matter because the slope of a line is the same over the whole function. All right, well, let's look at number 1. It's written in y equals mx plus b form. Well, my m is my slope, so 3 is my slope. All right, number 2, it's not quite written in mx plus b form, so let's use our sorting tool to just leave the 2y where it is and move the x to the other side, and it looks like we need to make it a negative x when we do that. Plus 14. So if I were sorting, I would say y terms and not y terms. Well, since y isn't totally alone yet, let's divide everything by 2. And we end up getting y equaling negative, well, that's just a 1, so negative 1/2 x plus 7. Ooh, I have a negative slope here. Y equals mx plus b, so negative 1/2 is my slope. So obviously a negative is much smaller than my positive 3 that I have here. Part 3, this is weird. Y equals 7. What does that look like? Well, let's graph it. Y equals 7. This is just going to help me to see whether or not my line is undefined or if it has a slope of 0. So where is y 7? Y is 7 there and all the way across. So what we did in Unit 2 can help us a lot. And this type of line actually has a slope of 0. So which of the following has the smallest average rate of change? That would be 2 because it's negative. Okay, 5, we're almost done. 3 linear functions are graphed below. Which one has the greatest slope? Which one has the greatest slope? That just means the steepest slope. So which line is the steepest? Well, let's calculate all of their slopes. Here's f of x. So how is that growing? Well, you go up 2 to the right 1, up 2 to the right 1. So f of x slope is up 2 to the right 1, which is equivalent to 2. All right, how about h of x? Or g of x is a little bit easier to find. So there's a good point for g of x in there. So what do? We go up 1, 2, 3, to the right 2, up 3, to the right 2. So g of x is up 3, to the right 2, which is the same as 1.5. And lastly, h of x. All right, here's h of x. Well, that's weird. Okay, there's a good point to use. And we have to go from there to there, it looks like. Okay, so up 1, 2, 3, 4, 5, to the right 1, 2. So that's h of x. We went up 5, went to the right 2, which is the same if you divide 5 by 2. You get 2.5. So my greatest slope would be h of x. Some of you might have said, well, you know what, Mrs. Ruscio, this line just looks steeper, and you could definitely have reasoned that way.